This is exam 3, practice exam. This covers chapters 12 and 10, and they are mixed up together. So any of the ones that are about finance, that would be from chapter 10, and then the problems dealing with probability, that would be from chapter 12. So let's start with number 1. Landon Wallen is an auto mechanic who wishes to start his own business. He will need $4,700 to purchase tools and equipment. Landon decides to finance the purchase with a 60-month fixed installment loan with an APR of 6%. Part A is determine Landon's finance charge, and Part B is determine Landon's monthly payment. So for this one, they're giving you the APR table, so you can use that. We know that we're financing here for 60 months, so we're going to look at the 60 months row. And then we have a 6% APR, so it would be this column. And so where those intersect, that's what we want to use. So we're going to be looking at the 16. So the finance charge is $16 for every $100 financed. So since he's financing $4,700, that would be 47, right? So 47 times 16 is $752. So that is his finance charge, $752. Okay, so he's borrowing $4,700 and the finance charge is $752. So if you add those together, you will get $54.52, which is the total he will need to pay back. And the reason you need to do that is because you're going to use that to find the monthly payment. So now that you know the total he's paying back, so this is the total he's paying back, you will divide that by the number of monthly payments he's going to have, so 60. When you divide that by 60, you get $90, and rounding to the nearest cent, 87 cents. That'll be his monthly payment. All right, number 2. The data to the right represent the population of 20 of the most populous cities in the world, in millions of people, rounded to the nearest 100,000. Use these data to construct a frequency distribution with a first class of 7 to 7.9. Fill in the missing classes and their frequency for each class below. Okay, so we're just going to fill in the classes first. So you can see that on the left-hand side, it's going to go 7.0, 8.0, 9.0, 10, 11, 12, and 13. And then on the right-hand side of the class, it ends in a 0.9. So this will be 8.9, 9.9, 10.9, 11.9, 12.9, and 13.9. All right, so there are the classes, and now the number of cities. You're simply going to count how many of numbers are there. So in other words, the first class is 7.0 to 7.9. So we want to look at the chart and see how many numbers lie within that range. So we will have 1, 2, 3, 4, 5. So 5 of the numbers are between 7 and 7.9. Then we'll do 8 in the 8s. So 1, 2, 3, that's it, 3. And then 9s, 1, 2, 3, 4. And then 10s, we have 1, 2. Then back to red for 11, we have 1, 2. We have none that start with the 12. And then we have, let's see, 1, 2, 3, 4 in the 13s. And then it tells us the total is 20. Number 3. Assume that a sample of bivariate data yields the correlation coefficient R indicated. Use the table on the right for the specified sample size and level of significance to determine whether a linear correlation exists. Okay, so we want n is equal to 7. So here is n equals 7 at a 0.05 significance level. So that's this column. So we can see that the intersection here is this number, 0.754. So now we want to compare 0.754 to the critical value of negative 0.83. And so remember that when you're comparing the R value, the correlation coefficient, you're looking at the absolute value of that. So the absolute value is just the positive value. So we're comparing 0.83 compared to 0.754. If your R is greater than the value from the chart, then a correlation does exist. So since 0.83 is greater than 0.754, we can say that yes, a linear correlation exists. Okay, number 4. Use the standard normal distribution table to determine the percent of data between the z-values of negative 1.69 and 1.99. So this will be a pretty large amount. So here is just a sketch. Okay, and so we have negative 1.69 might be somewhere over here, and 1.99 will be somewhere over here. Remember that 0 is right in the middle, okay, and then half of the data lies to the left of 0, and half of the data lies to the right of 0. And so a portion of the data will lie between these two z-scores that they gave us. So let's look at the tables that they give us. They give us the table of areas to the left of z when z is negative, and the table of areas to the left of z when z is positive, and that's it. Okay, so they're all to the left of z. So here is what you need to do for this one. We have two z-values. So first we're going to find what is the area to the left of negative 1.69. So that gives us the little part I just colored in blue. But that's not the area we want, right? I'm going to highlight the area we want in green. We want this part, right? Okay, the other part of the table will give us the area to the left of 1.99. Well, that will be, okay, well that's looking good, right? But remember, it's going to give us all of this as well, which we don't want. So what we're going to do is we're going to subtract the areas. If we take what is hatch marked here in red, right, that's all the way to the left. If we subtract off what we have here in blue, red minus blue will give us that green part. So that's what we're going to do here. So first we'll find the area to the left of negative 1.69. So we'll use the chart. Okay, so this is going to be the blue. Negative 1.6 is here. And then we have to look at 9.09. So where it meets is 0.0455. So this area is 0.0455. That's the area to the left of negative 1.69. Now I want to find what I have marked in red. That's going to be the area to the left of 1.99. So I'm going to go to this chart. Okay, 1.9 is here. 1.99, so I'm looking here, and you can see it intersects right here, 0.9767. So 0.9767. So it's all of this. 0.9767 is the area all the way from the left all the way to 1.99. And so now to find the area that's just green, we subtract these two numbers. So 0.9769 minus 0.0455. And that gives us 0.9314. Okay, so 0.9314. And that will be the area that we're looking for. I just realized I was looking at the key and I see that we're off. It's because I didn't copy down a number right. So this should be 9767, not 9. I just checked the chart. And this should be 9767. So this will be 9312, 0.9312. And so that would be the correct answer here, okay? So again, be careful looking at the chart. Double check your work on a test, right? And so now this is the decimal, so we want to change it to percent form. So we would move the decimal over twice or multiply by 100. So that would be 93.12%. Okay, number 5. Determine the range and standard deviation of the prices of digital cameras shown below. So for this one, the range is simply subtracting the greatest value minus the smallest value. So the greatest value I see is 296, and the smallest value is 93. So 296 minus 93 will give us 203. So the range of the prices is $203. To find the standard deviation, you can use your formula, but again, you have access to a calculator that will do this for you. So you want to use the meta calculator link that I gave you, and you type in your 8 values, your 8 digital camera values, and then it'll give you the standard deviation so that you don't have to do it all by hand. So the standard deviation, rounded to the nearest cent, is $68.48. So make sure you familiarize yourself with the calculators because they will do this for you. Number 6, a man uses a loan program for small businesses to obtain a loan to help expand his vending machine business. The man borrows $20,000 for 3 years with a simple interest rate of 1.7%. Determine the amount of money the man must repay after 3 years. So here the key is simple interest. So interest is equal to principal times rate times time. So your principal is $20,000. The rate is 1.7%, so that would be 0.017 as a decimal. And then the time is 3 years. So once you multiply all of those numbers together, you will get the amount of interest. So 20,000 times 0.017 times 3. So $1,020. That's the interest. Now remember, they want to know how much he must repay. He has to pay the interest, but he also has to repay the amount he borrowed originally, which is $20,000. So $20,000 plus $1,020 would give us $21,020. So again, remember to add up the original amount plus the interest to get the amount that he has to repay total. Number 7, to help pay for a class trip at the end of their senior year, the sophomore class at a high school invests $1,300 from fundraisers in a 30-month CD, paying 4.7% interest compounded monthly. Determine the amount the class will receive when it cashes in the CD after 30 months. So for this one, you can simply use your TVM calculator to put this information in. So you will have the $1,300 is the present value. The annual percentage rate is 4.7%. Okay. So this is your rate. And then you're putting in the 30 for the periods. Okay, so that is going to be input for the periods. And then you just click on future value. And when you click on future value, you will get $1,400 $461.75. Number 8. Ted tossed a frisbee as far as he could 15 times. The following distances in feet were recorded. Find each measure of central tendency. So again, I would recommend that you just put this into the meta calculator and see what they give you there. When you put this all into the calculator, you will find the following. So the mean, and if you wanted to do the mean, remember you just add all these up and divide by 15. The mean is 179.2. 179.2. The median is 183. So remember, the median value is the one that's in the middle. So if you ordered all of these in order from least to greatest, you would find the middle value, which is the median. The mode is the one that appears the most often. And in this case, there's not any repeated value, so there is no mode. And then the mid-range is 183. Okay? Let's look at number 9. The following statistics represent weekly salaries at a construction company. Okay, so they're giving us, they don't give us each individual salary. This time they're giving us the mean, median, mode, first quartile, third quartile, 87th percentile, and then they're going to ask us questions related to the information that they gave us. So let's see if we could figure these out. The most common salary. Well, remember, the most common is the number that appears the most often, which is the same definition as the mode. So the one that appears most often would be the mode. So that would be the most common salary. So $510. The salary that half the employee's salary surpasses is, so remember that half the employees, that means right in the middle, right? So that's at the median. The median is right in the middle. It's at the 50th percentile. So 545. The percent of employees' salaries that surpass $610 is, so here we see the $610. That's in the third quartile. So remember, the third quartile is like the 75th percentile. Okay, so the percent of employees' salaries that surpassed that. So if that's at the 75th percentile, that means that $610 is more than 75% of the employees. 25% of the employees make more than that. So 25 would go here. Okay, so the third quartile, or the 75th percentile, means that 75% of the employees make below $610, and 25% of the employees make above $610. All right, the next one. The percent of employees' salaries that were less than $445. So here's 445. That's the first quartile. The first quartile is the 25th percentile. This means that 25% of the employees make less than this, and 75% of the employees make more than that. So it wants to know the percent of employees' salaries that were less than $445. That would be 25. Okay. The percent of employee salaries that surpassed $679. So since this is the 87th percentile, that means that 87% of the employees make less than this amount. And then 100 minus 87 is 13. So 13% make more than that. So the percent of employees' salaries that surpassed $679 is only 13%. Finally, if the company has 100 employees, the total weekly salary of all employees is, this is where you want to use the mean. So the mean is the average amount that each employee earns. So you find that by adding up all the salaries and dividing it by the number of employees. So this is the average. So all you need to do then is multiply the mean, which is 585, times the number of employees that are there, and that will give you the total weekly salary that the company pays for all the employees. So that'll be $58,500. Number 10. Use the sinking fund formula shown to the right to determine the semi-annual payments with 9% interest are compounded semi-annually for 7 years to accumulate $19,000. So for this one, you simply want to plug everything into the formula on the right. So the A is 19,000. The R is 9% as a decimal, so 0.09. The N, since it's semi-annually, that's twice per year, so that's 2. And the T is 7. So simply plug that information into the formula, put it in your calculator to get the answer. When you do that, you will get $1,003.59. Number 11. The population of a country has been decreasing for several decades. In 1990, the population was about 137 million. In 2010, the population was about 133 million. Determine the percent decrease in the country's population during this time period. So whenever you're trying to find a percent increase or a percent decrease, you always want to find the difference and then divide that by the original amount. So the difference divided by the original amount. So 137 million minus 133 million is 4 million. So that's the difference. And that's 4 million over 137 million, which is the original population. And that will give you the percent decrease. I was going to say increase, but it's not. It's a decrease, right? To find that, you get 0.0292, and then it wants to 1 decimal place as needed. Again, remember that this is in decimal form. So first we want to multiply by 100 to get it in percent form. So that'll be 2.9%. So it's decreasing by about 2.9%. Number 12. Anna is buying a house selling for $225,000. To obtain the mortgage, Anna is required to make a 15% down payment. Anna obtains a 30-year mortgage with an interest rate of 5%. So part A is determine the amount of the required down payment. So if the amount of the house is $225,000 and she has to make a 15% down payment, 15% as a decimal is 0.15. We're simply going to multiply those together. So 225,000 times 0.15, we get $33,750. So that's how much she's going to have as a down payment. Part B is determine the amount of the mortgage. So the amount that's mortgaged is the value of the house minus the down payment. Okay. So that's $191,250. Now part C is determine the monthly payment for principal and interest. So you can use the chart below, or you can use the TVM calculator, whichever you prefer. So let's look at the chart. Okay, so we need the interest rate and the number of years. So it is a 5% interest and a 30-year mortgage. Okay, so 5% interest is here and a 30-year mortgage is here. So we can see that the intersection is right here. So that is the monthly principal and interest payment per $1,000 of mortgage. So if you're going to use a chart, what you do is you take the $191,250 and divide that by 1,000. Okay, So you take the amount of the mortgage and divide it by 1,000. And that's usually what it is in thousands, but whatever it tells you in the title of the chart, that's what you would divide it by. When you do that, you get 191.25. You then multiply that by whatever number you find in the chart. So in this case, it's 5.36822. So times 5.36822. And I get $1,026.67 to the nearest cent. So $1,026.67. So that's using the chart. And again, this should work if you put it in the TVM calculator as well. So those are your two options. You can use the chart or use the calculator, whichever is easier for you. Number 13, use the compound interest formula to compute the total amount accumulated and the interest earned. $8,000 for 4 years at 6% compounded daily. And so for this one, you can either use the compound interest formula, or you can use the compound interest calculator that I provide for you. It's on the TVM calculator, there's another link on the left that says compound interest calculator. You would just use that. This one is a pretty straightforward formula though, so I'll write it here in case you want it. So you could just plug it in to your calculator, but again, you can use the TVM calculator as well. So 8,000 is the principal. Okay, and then let's see, 8,000 is the principal. The R is the interest rate as a decimal, so 0.06. N is the number of times it's compounded. We're saying 360. And T is 4. Okay, so we would just plug that in the formula or in the calculator, whichever way you want to do it. And then see what you get, okay? So the total amount accumulated after 4 years, this gives you the total amount, $10,169.79. The amount of interest earned, so to find the interest, you simply subtract what you just found minus the 8,000, which was the principal, and you get $2,169.79. All right, there's only 15 problems, so I've got 2 more to go. Assume that the mathematics scores on the SAT are normally distributed with a mean of 500 and a standard deviation of 100. What percent of students who took the test have a mathematics score below 610? Okay, so normally distributed, that should automatically trigger the z-scores. So that is what we're really dealing with here. And what they want you to do is standardize these scores. So remember that a standard normal curve has a mean of 0, has a mean of 0 and a standard deviation of 1, right? And so to get these into z-scores, the mean will end up being 0. Right now it's 500. And to find a specific z-score, what you do is you take that score, subtract off the mean, and then divide it by the standard deviation. So you would do 610 minus 500, that'll give you 110, divided by 100 would give you 1.1. So the z-score for 610 is 1.1. And you can always find the z-score by subtracting off the mean, which they have to give you, and dividing by the standard deviation. Again, they'll give you that. So the next thing we want to do is get an idea for what's going on. So we're going to draw a picture. We have a z of 1.1. So let's say that's here. Okay. What percent of students who took the test have a mathematics score below 610? Below, so I'm going to put 610 in parentheses. That's all of this, right? It's the area to the left of this. So that's perfect because that's what they're going to give us in the chart. So we like area to the left. Perfect. So we're looking for 1.1. Okay, so we have 1.1. And since it's exactly 1.1, we're looking for 1.10. So that would be here. So the intersection is here. 0.8643. 0.8643. Okay, so 0.8643. That's the area under the curve to the left of the standard z-score of 1.1. Put this into percentage form, so move it over to the right twice or multiply by 100. You get 86.43. So 86.43. All right, the final one, number 15. The following table shows the weights in hundreds of pounds for 6 selected cars. Also shown is the corresponding fuel efficiency in miles per gallon for the car in city driving. Use the data provided in the table to complete parts A through D. All right, so let's see what we've got here. Determine the correlation coefficient between the weight of the car and the fuel efficiency. Okay, so these we're going to be determining a correlation coefficient. We're going to be finding the line of best fit. So I would recommend using the calculators that, again, provided for you in the Word document. So go ahead and put these values in so that you can find this. Remember that these calculators I'm giving you links to do this for you. So you don't have to have it all memorized. You don't have to, do it all by hand. So when I put these pieces of data into the X and Y charts in the calculator, I found that the correlation coefficient, the R, is negative 0.6462. Okay. Oh, and it says around to 3 decimal places, so take the 2 off. So negative 0.646. Part B, determine whether a correlation exists at the 0.01 level. Okay, do they have a chart here? There we go. All right, so I've got to go back. I have 1, 2, 3, 4, 5, 6. Okay, N is 6, and then 0.01. So N is 6. The 0.01, so 0.917. So we're comparing our R to 0.917. And remember, we're comparing the absolute value of our R. So we're comparing 0.646 to 0.917. Our number is smaller than 0.917. So we can say a linear correlation does not exist. Remember, the R has to be greater than that number in order to say a correlation does exist. Part C, determine the equation of the line of best fit. Okay, so again, there is, it does it for you on the linear regression calculator. So for the first part, the part before X, that's going to be negative, and it says round to 3 decimal places. So 0.477 X plus 36.795. There are formulas for you to find it. It will take you a long time. Or again, you can use the linear regression calculator that I provide a link for and let it do the work for you. Part D, use the equation in Part C to estimate the fuel efficiency of a car that weighs 3,200 pounds. So this 3,200, right? This 3,200 is going to be what X is. So X is already in hundreds of pounds, so you're just going to plug 32 in there. So it's going to be negative 0.477 times 32 plus 36.795. You're going to plug that in your calculator and see what you get. Okay, and I got 21 point, how many decimals? 3 decimals. 21.531 is what I got. Let's see, 21.531. The key says 21.523, and I am guessing that they are using the non-rounded version, but since you have the rounded version right here, you can just use that. And so if your decimal is off a little bit, that could be why. If you have any questions after looking over this, please email me. Remember that you should do the practice exam as many times as possible to ensure that you see the full picture, the full pool of questions that could be asked of you on the actual exam.